Hey everybody, we're gonna get started in a few minutes. Looks like there's only just a couple people who've signed in so far, so I'm gonna wait for at least a few more people. Hopefully, I mean we've got about 30 people in the class, so it'd be nice if we got like 10 people watching it live. So if you notice that you have a couple of friends who aren't watching it yet, maybe shoot them a text or something like that. Let them know that we're starting now. I'll wait probably a few more minutes. You guys can say hi to my cat, Goose. One of my two cats. The other one's sleeping. Oops. Okay, so it looks like we got 5 people right now. Hopefully we can get that number to 10, and then we'll jump right into it. Okay, we're getting there. 7 people. All right, got another person here. We got 8 people. Come on, let's even get to 10. Then we'll get started. If there's not 10 people by 2:30, then we'll just get started. So whatever happens first, 2:30 or 10 concurrent viewers, then we'll get started. Oh, 9 viewers. Getting there. Oh, down to 8. Come on. Oh, back up to 9. Oh, there's 10. Okay, we'll get started in just a second. I'm going to finish this email, and then we're going to do this. So while I finish this email, just if you have any questions, now would be a good time to ask. They could even just be like, oh, question number 9 on section 4.2 or something like that. So here we go. Can you go over how to find the domain and range of a piecewise function? I could, but we haven't done that in class. And who's your teacher? Am I your teacher? Did I do a bad job of explaining something that we haven't covered yet? Who's this Jim? Who is Jim? Are you in our class? Domain and range of a piecewise function. Yeah, we'll leave that for later. Let's focus on stuff that we're in the middle of. I'm gonna finish this email later. Okay. You live in Florida. Huh. Well, sorry, but yeah. So I'm gonna focus on my own students. You're welcome to hang out in the stream, but yeah, I'm gonna focus on the stuff that I'm teaching my kids. Okay, so let's get started then. Let's do. So I'm gonna just start off with a few questions, get kind of warmed up a little bit. So the last thing that we have been looking at is completing the square. So let's start completing the square. And what I'd like to do today is, hopefully we'll get to this, but we might not have time. But I would like us to look at something called the quadratic formula. Maybe you've heard of it, maybe you haven't. We'll see. We'll see how it goes. Okie dokes. Let's get started. So so let's just do some exercises here. So oops, it's too thick. Exercises. Okay, so I'm going to just kind of choose several like random exercises and see how that goes. So yeah, let's try. Let's try number 3. Let's do 3B. Let's do 3B on page 240. Okay. So let's do this. So I'm gonna write this in. So write in vertex form. Vertex form. Okay. So essentially, what I'm going to be doing, what you should be reading when you say when you hear about vertex form, is to complete the square. So complete the square. Okay. So let's start off by writing the question down. So we've got 5x squared minus 20x minus 1 equals 0. And I'm going to complete the square. So first up, what I'm going to do is I'm going to divide the whole equation by 5. So when I'm going to factor out this 5. This is going to give me 5 times x squared minus 4x minus 1 over 5, all equal to 0. Now I'm going to do a quick little trick here. I'm going to multiply both sides of the equation by 1/5, and you'll see why I do that in a second. So I'm going to multiply this by 1/5. I'm going to multiply this by 1/5. And this is all just going to go down to 0, right? Because 0 times anything is just 0. And then this is also going to disappear because 1/5 times 5 is just 1. So this just is equal to 1. So I'm going to be left with, I guess I don't need even brackets anymore, x squared minus 4x minus 1/5. Okay? So far that looks good. Now what I want to do is, well, I actually want to complete the square. So just to make things really clear, I'm going to change the color of this. So now this is in pink. So what's in pink is the thing that I'm going to complete the square with. So what I do is I take this minus 4. So I take this negative 4 and I divide it by 2 and then I square it. So negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. So that means I'm going to add 4 and subtract 4 from this whole equation. So I'm going to have x squared minus 4x plus 4 minus 4, and then I'll actually write this all in blue. So minus 4 minus 1/5. And that's all equal to 0. Okay, so all of this I'm going to sort of combine into one, and then all of this is a perfect square. So I've got x squared minus 4x plus 4, and what I have, so that is going to end up being x minus 2 squared, and what's left is negative 4 minus 1/5, so that's going to be negative 21/5, because negative 4 is the same thing as negative 20 over 5. So I really just put that over a common denominator of negative 5. And all of this is equal to 0. And we're done. This is in vertex form. Or in other words, I guess the way the textbook wrote it is that they want us to write it in the form a times x minus p squared plus q. So we did that. Okay, so that's a nice little warm-up. I thought maybe we could do a couple more questions. So yeah, we'll do some where we solve the quadratic equation by completing the square. So let's try that one. Okay. So let's do 6. Question 6, and let's do, let's say 6C. Okay, so we'll do 6C. By the way, if you have any questions, just, don't hesitate to throw them in the chat. I've got my eye on the chat here. So let's do 6C on 4.3. So I'll do 4.3, 6C. Okay, there we go. And this is 3x squared plus 6x plus 1 equals 0. Okay, so that looks good. And we're going to complete the square. So I'm going to solve this by completing the square. So let's see here. I'm going to start by factoring out a 3. So I'll have 3 times x squared plus 2x plus a third, and that's all equal to 0. Okay, so there's that. Next up, I'm going to complete the square. So this portion is the portion that I'm going to complete. And actually, before we do that, let's get rid of that third. So I'm going to multiply both sides by a third, and now I've got that cancels out, that cancels out. So I'm left with just x squared plus 2x plus a third equals 0. And then I'm going to complete the square. So I've got x squared. I'm going to take this 2, and I'm going to do 2 divided by 2 squared. So that's equal to 1 squared, which is 1. Okay, so I've got x squared plus 2x plus 1. And then I'm going to subtract the 1, because if I add 1, I have to subtract it as well. And I've got minus 1 plus a third, and that's all equal to 0. Okay, now I'm going to factor the perfect square, so I'm going to write it as a perfect square. So that's going to be x plus 1 squared. And negative 1 minus a third is negative 2/3, and that's still all equal to 0. Now I want to solve for x, right? That's what I've been asked to do. So I'm going to do this by moving that to the other side. So I've got x plus 1 squared, and that's all equal to 2/3. Okay. So next up, I'm going to take the square root of both sides. So I'm going to do square root, square root. Now keep in mind, when you introduce your own square roots, you have to write the plus or minus symbol, because it's quite possible that what's inside here could have been negative, in which case it would turn out to be positive because of the exponent of 2. So when you introduce a square root symbol, you have to write plus or minus. Okay. So next up we have, let me zoom out a little bit. I've got x plus 1, because I got rid of that squared. X plus 1 is equal to plus or minus the square root of 2/3. Okay. And finally, I've got that x is equal to negative 1 plus or minus the square root of 2/3. Okay, and that's that. That's the solution to this this quadratic equation. Okay. So you guys are awfully quiet in the chat. Not a whole lot going on. Looks like we're back down to just 9 students here. So that's really too bad. I was hoping that a few more people would have shown up. It would have been nice to have at least a third of you here, but I understand that there's a lot going on in our lives right now, so I get it, but it's too bad that this isn't reaching as many people as it could. Okay, so if there's no more questions, I mean, there hasn't been any questions at all so far. What we're gonna do is we're gonna start looking at the quadratic formula. So the quadratic formula kind of goes through all of this whole process that we did, and it kind of generalizes it to any equation that you could possibly have. So let's take a look at what that looks like. Yeah, let's see if we can derive the quadratic formula. Okay, so let's have a look here. So let's take some notes. So we're going to talk about the quadratic formula. Okay, quadratic formula. Okay, and I'd like to introduce just a few terms for us. So we've looked at the X-Intercepts a lot, and the X-Intercepts have a few different terms. So let's talk about the X-Intercepts of a quadratic function for a second. Okay. So the X-intercepts on a quadratic equation, or a function, we're going to think of them as functions now. So yeah, the X-intercepts on a quadratic function are when the function passes through the x-axis In other words, this is where the function is equal to 0. Okay? That's where the function is equal to 0. Okay, so this has a special term. So we call these points the roots of the function. Okay, so I'm hoping that we've seen that the roots of a function, they come up quite a bit. So they correspond to a lot of different things. So for one, they correspond to where the function passes the x-intercept. And another thing that they correspond to is when we actually solve the quadratic equation, when everything is set to 0. So there's a lot of stuff going on with the roots, and it's going to be really important to be able to calculate those roots really quickly. So the quadratic formula, it kind of finds all those roots that we're looking for all at once. Okay, so let's take a look at what this looks like. Okay, so the quadratic formula calculates the roots of a quadratic function very easily. If the quadratic function has no roots, then the formula will tell us that as well. Okay, what does that mean? Well, not all quadratic equations pass the x-axis, right? Not all of them pass that x-axis. So we don't always have x-intercepts. So let's take a look at what I'm talking about. So just really roughly, you could imagine a quadratic function looking something like this, right? In which case there are no roots, i.e. no x-intercepts. Okay, so that's not good. So we need to figure out how we would figure that out. Like if we have a formula that just tells us what those roots are, but some quadratic functions have no roots, then hopefully our formula is going to be consistent with that. That there's going to be something in our formula that will tell us, hey, you got to be careful. There's no roots in this case, and our formula actually turns out to work out that way. So what we're going to do now is we're going to derive this formula, and hopefully this is something that you've got enough room in your memory to memorize, because it is something that comes up quite a bit. And being able to memorize this formula is going to save you a whole lot of time, because as you can see, going back to these last examples, like this takes a lot of time, and the formula basically just goes straight to this. So it'd be pretty nice if we could start off with a quadratic equation and immediately go to the solution, and that's what the quadratic formula does. So it'll tell us exactly what the roots of our quadratics are. So we're going to start off with just a general equation in standard form. So let's call this deriving the quadratic formula. Okay, So we're gonna derive this quadratic formula, and it's really not too bad. Really, all we're gonna do is we're gonna complete the square of just a general quadratic equation. So what I mean by that is our goal is to find the solution, or I should say find the roots of, let's do ax squared plus bx plus c, and that's going to be our polynomial, our quadratic expression. So we're going to find the roots of this quadratic, and when we do, that'll be our formula. So in other words, we want to solve for x when ax squared plus bx plus c is equal to 0. Okay, that's our goal. That's what we're going to try to do. And it turns out it's really not that bad. We've been doing it pretty much this whole time, except now we've just got variables instead of actual numbers. So we're just going to do the whole thing of, solving this quadratic equation, except instead of having real numbers, we're just going to have variables. So it's the same process. We're still going to solve for x. However, we've got variables in front of our other variables. So let's start off by writing the equation down. So we've got ax squared plus bx plus c all equal to 0. And now I'd like to factor out that a. So I'm going to write this as a times x squared plus b over a x plus c over a. And that's all equal to 0. Okay? Now I'm going to divide both sides by a, or in other words, multiply both sides by 1 over a. 1 over a. And then, just like before, these cancel, and I'm left with x squared plus b over ax plus c over a all equal to 0. And next up, I'm going to complete the square of this portion. So this gives me x squared plus b over a times x. And I'm going to take this term, b over a, and I'm going to divide it by 2, or in other words, multiply it by 1/2 and square it, which gives me b over 2a squared, which is b squared over 4a squared. Okay, so I'm going to add and subtract that. So I've got plus b squared over 4a squared minus b squared all over 4a squared. Okay, and I still have this plus c over a, and it's still all equal to 0. So this portion right here, this is a perfect square, and this is equal to x plus b over 2a squared. And if you're wondering where I got the b over 2a from, I got it from here. Because that's what, when I square this, that's what b squared times 4a squared is going to be equal to. Okay? And let's put this over a common denominator. So I need to multiply the top and bottom by 4a. So I got 4a times 4a. And I'm left with b squared minus 4ac all over 4a squared, and that's all equal to 0. Okay, now remember, I'm looking to get x, so this is the only x that I have in my equation, so I'm going to start moving everything that's not x to the other side of the equation, and we'll see what we get. So I finally get x plus b over 2a squared equals, when I'm taking all of this and I'm moving it to the other side. So I've got, this is all equal to b squared minus 4ac all over 4a squared. And now I take the square root of both sides, plus or minus, and I'm left with, well, x plus b over 2a is equal to the square root of, or plus or minus the square root of b squared minus 4ac all over 4a squared. But keep in mind that this is equal to, well, the numerator is just b squared minus 4ac, and we got plus or minus, all over the square root of 4a squared. Remember that a radical, if I have something like this is actually equal to the square root of a over the square root of b. So that's really all I did here. And the denominator there, that's a perfect square, so I can actually take that square root. So let's not forget that we have an equation here, so I still have to write the other side. So I've got b over 2a. Well, the square root of 4a squared, that is 2a. So we got plus or minus the square root of b squared minus 4ac, and I've got that this is x plus b over 2a. Now, all I have to do is just isolate x. So I'm gonna take this and bring it to the other side. So I've got something that looks like this. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And finally, this is all equal to x equals, well, these are common. They have a common denominator. So I've got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula. So now that we have the quadratic formula, we can actually use this to solve for pretty much any quadratic equation that we please. So let's try it out on a few different quadratic equations. So let's try one from our textbook here. So let's use the quadratic formula. I'm going to refer to it as QF from now on. So let's use the quadratic formula to calculate the roots of this function here. 9x squared plus 12x plus 4. So that would be y equals 9x squared plus 12x plus 4. Now you could certainly do this the old-fashioned way. You could try to factor it, or you could complete the square, and you'd still be able to find the roots of this quadratic. But using the quadratic formula, we can just go straight there, basically in one step. So basically what we're going to do is we're going to say, well, the roots happen when this is equal to 0. So when I've got 0 is equal to 9x squared plus 12x plus 4. That means that using the quadratic formula, that x is equal to, well, this is my a, this is my b, and this is my c. So using the formula, I get that, well, negative b, that would be negative 12, plus or minus the square root of, well, b is 12, so I've got 12 squared, minus 4 times a, so I've got 4 times 9 times c, which is 4. And that's all over 2 times a. So that's 2 times 9. And that's that. So let's see what this is equal to. So I've got that x is equal to negative 12 plus or minus the square root of, well, 12 squared is 144. So 4 times 9 is 36. And 36 times 4, let's quickly do that. So that's 24. 12 plus 4 is 14. So I've got 144 minus 144. And that is all over 2 times 9. So let's take a look at that. So here I've got that x is equal to negative 12 plus or minus, well, the square root of 144 minus 144 is the square root of 0 all over, oops, that should be 18. And finally, this is all equal to, well, negative 12 plus or minus 0. Doesn't matter if you're going to add or subtract. If you just add or subtract 0, then nothing happens. So this is equal to negative 12 over 18. And I can reduce that. These are both divisible by 3. In fact, they're both divisible by 6. So let's say that this is equal to negative 2/3. Okay, so we only have one root of this equation. So let's take a look at what that means. What does it mean if we only have one solution? So I'm gonna quickly head over to Desmos. Okay, Desmos. Here we come, and let's graph this. Let's see what this function looks like. So let me just plug in my keyboard real quick. Okay, so close that down. And what do we want here? We had, what was it? Where'd it go? 9x squared plus 12x plus 4. So I've got 9x squared plus 12x plus 4. And let's take a look at what happens at the x-axis. Aha! We only intersect the x-axis at one single point. And that is the point negative 2/3, right? Negative 2/3 is negative 0.66667, or however you want to call it, right? Negative 2/3 is 0.6 repeating, right? So that's where that comes from. Let's think a little bit about what the different possibilities are, right? So this only has one root. So this function has exactly one root. It's at negative 2/3, right? It's right smack dab right there. So what are the different possibilities? Okay, well, we have three possibilities. Okay, possibility 1. Okay, possibility 1 is 2 roots. Okay, so that would look something like this. So here's our x and y axis, and maybe our parabola looks something like this. Okay, so we would have 2 roots right there and there. Okay? Oh, okay. So Ethan, I'm going to get to your question in just a second, okay? Just 1 second. Okay, so we would have 2 roots. So that's one possibility. Another possibility is, so let's call this possibility number 2. Okay, we would have 1 root. Okay, and this would look something like this. Okay, and this is what we had in the last question, where our vertex is that x-intercept. So here we would have 1 root, which is our vertex. So if our vertex is right on that x-axis, then that means that we only have 1 root. And the last one, so let's do possibility number 3. That would be no roots. Okay, and that would look something like this. So we would have something going up and down like that, and we would have no roots. So that would be this case, no roots. Okay. Okay, I'll be right back. I just need to use the washroom. Sorry about that. Just been live streaming for a couple of hours now. Haven't really had any breaks. Okay, so let's take a look at what these possibilities mean in terms of our formula. So someone in the chat just pointed out something interesting. So what would happen if we didn't have a 0 in this? Well, first of all, let's name this, because this is kind of the interesting part here, right? Because we've got a square root, and we're also adding and subtracting it. So this little portion right here has a special role to play in these different possibilities. So so the term b squared minus 4ac has a special role to play. In the quadratic formula. Okay, so let's write out the formula again, and I'm hoping that this is something that we're going to be able to memorize. I know that it's not the easiest thing to memorize, but we do need to memorize it at some point. So this is, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's the quadratic formula. So that b squared minus 4ac, let's put that in a different color. So b squared minus 4ac, let's turn that to, how about yellow? Okay, so this has a special term. We call this the discriminant. This is called the discriminant. Okay? So when the discriminant is positive, we have two solutions. One where we add, and another where we subtract. This is from the plus or minus, right? Because this plus or minus says that on the one hand you can add, and on the other hand you can subtract. Okay, so when the discriminant is positive, we have two solutions: one where you add, one where you subtract, and we'll look at a whole bunch of examples to sort of clarify this. So that's one possibility. So when the discriminant is 0, we have, well, let's see if we can figure out how many we would have before I just tell you. In the last example that we did, look at that, the discriminant was 0. and we had one solution. That was because we added or subtracted 0. It doesn't matter if I add 0 or subtract 0. It's the same thing. So I only have one solution. So when the discriminant is 0, we have one solution. Okay? This is because it doesn't matter if we add or subtract 0. We get the same thing. And finally, when the discriminant is negative, we get no solution. This is because we cannot take the square root of a negative. Okay? So those are our three options. Either we have a positive discriminant, and that would give us two solutions, or two roots, if you will. You could have a discriminant of 0, which would give us a single root. And if we have a negative discriminant, then that tells us that we have no solutions, because you can't take a square root of a negative number. Now, I do have to sort of put a little asterisk on here. Any mathematicians who are watching this would immediately be screaming at me, because it turns out you can take a square root of a negative number, but there's some technicalities that we have to be a little bit careful of. So note, you can take negative square roots but this would give you a complex number. So we're not really going to talk too much about complex numbers in this class, but the idea is that if you wanted to, we could just say that this, the square root of -1 is equal to this imaginary number I. And if we have that, well, then that means that I could take the square root of, let's say, -4, and that would be 2I. Now these are complex numbers, so a few times we've looked at different number systems, and we've looked at the natural numbers, we've looked at the integers, we've looked at the rational numbers, we've looked at the real numbers. These guys, these 2I and this I, this sets us up for complex numbers. So what you could say, if you wanted to, is you could say, well, there are roots of this polynomial, but they're complex roots. So one thing that we would say, so when we have a negative discriminant, we often say that there are no real roots. And what we mean by real is not like fake or valid or anything like that. When I mean real, I mean like a real number. So that there's no real roots, but there would be complex roots. Okay? So how do you take the square root of a negative number? That's cool. Yeah, it is cool. You can. And that's how you do it. You would just include a little I in your answer. So you would just take this. So like in this case here, if you wanted to take the square root of -4, well, you would just do it. You would just ignore the negative sign and say, okay, what's the square root of 4? That's 2. And well, because I'm taking the square root of -4, that means that I've got this little I here. So yeah, it is pretty cool. But that's a whole other area of math that you can really go down a very deep rabbit hole with that. There's a whole area of math called complex analysis that really focuses on what's going on with this little funny little number called I. So let's take a look at a few examples and see what the quadratic formula looks like in practice. So keep in mind we're gonna wrap this up in about 10 minutes or so. So I'll probably have time for maybe one maybe two examples. In the meantime, I'd like you to try some of these questions yourself. So I'm going to assign just a little bit of homework. I recognize that we're all in different sort of situations right now due to the this quarantine. So just keep in mind that like if you're struggling to keep up, just do as much as you can. But let me know if you're kind of falling behind or if you're unable to keep up, because it'll help me kind of pace myself, because as you know, usually in class we have lots of work periods and that kind of thing, and I can kind of monitor everyone's progress, but I can't see anybody's face right now, and not only is that really sad because I miss you guys, but it also means that I'm not really sure where you're at in your academics. So you do have to tell me if you're kind of falling behind. I should say that going forward, I'm still in the midst of looking for different assessment tools, or in other words, how I can take assignments and stuff and give you grades and that sort of thing. So I'm still looking into that. I'll probably have an answer for you sometime tomorrow. In any case, stay tuned. But I am gonna have to start taking in some assignments and stuff like that, because we can't really have tests right now. So we'll see how this goes. Anyway, let's do a few examples. Let's say, just gonna pull some out of the book here. Okay. So, e.g. No, that's not it. Here we go. e.g. So, I'm just gonna ask, how many roots does this quadratic equation have? Okay, so let's do it. We've got 5x squared minus 7x minus 1 equals 0. Okay, so in this case, well, a is equal to 5, b is equal to -7, and c is equal to -1. Okay, so our discriminant, that is going to tell us everything we need to know about how many roots we have. So remember, it's b squared minus 4ac, so I'm going to write -7 squared minus 4 times a, which is 5, times c, which is -1. And so that gives me 49 minus, 4 times 5 is 20, and then I've got -1, so I'm subtracting -20, so I've got plus 20, and this is 69. Nice. So this is positive, so that means that we have two solutions. So we have two, I should say roots, because the discriminant is greater than 0. Okay, now let's just verify that, and let's go to Desmos and see what this graph actually looks like. So I've got 5x squared, so I've got 5x squared minus 7x, oops, not minus 7x, minus 1. And look at that, I have two roots, one there and one there. Keep in mind, I didn't have to calculate it. All I did was I just asked how many are there, and there's 2. Okay, let's see if we can squeeze in one more example, and we'll call it a day. Let's do. Hold on one second. Just trying to find a good example here. Okay, excuse me. Okay, so how many roots does, let's see, y equals 3x squared minus 5x plus 9 have? How many roots does that equation have? Well, let's have a look. Let's see. So I'm going to find the discriminant. So A is equal to 3, B is equal to negative 5, and C is equal to 9. So the discriminant is B squared minus 4AC. B squared is negative 5 squared minus 4 times A, which is 3, and C, which is 9. And so I've got 25 minus, well, 4 times 3 is 12. 12 times 9 is 108. So I've got 25 minus 108. I don't even need to know what that is. I mean, what is it? That's going to be 83, I think. So let's call that, negative 83. Let me just double check. I would hate to put this on the internet and have a typo. So 108 minus 25, that's going to be 3, and then 10 minus 2 is 8. Yeah, it's 83. So this is equal to negative 83, so there are no roots. Very cool. So let's just verify that one more time. Take a look at that graph on Desmos. So we've got 3x squared minus 5x plus 9. So 3x squared, was it minus 5x? Minus 5x plus 9. And where did that even go? Oh yeah, look, it's all the way up there. So yeah, there's no roots. It does not pass the x-axis. So this quadratic function has no roots, and we were able to verify that just by looking at the discriminant. So in the chat we got, wait, this is such a faster way than what I would do. Oh my God, yeah. So it's way faster. So yeah, all you have to do is just take a look at that discriminant, and it'll tell you exactly how many roots you have. So it's pretty quick. So this would be the first thing that I would memorize, is the b squared minus 4ac, because that's the discriminant, and just having that on hand is going to be really useful. And then you can also remember that in the quadratic formula, the reason why we can't have a negative is because this is all underneath a square root symbol. Keep in mind that the discriminant has no square roots in it, but in the quadratic formula, the discriminant is underneath a square root. So if you're trying to sort of build up that memory, start off just by memorizing the discriminant, because this is the one that's going to come up the most. So if you can memorize the discriminant, then that'll really help you in a lot of different ways. I'm going to leave it at that. I'm not going to assign any homework for the quadratic formula just yet, but I do want to make sure that that we are doing our due diligence and keeping up with the homework. So I'd like us to keep working on 4.3 if you haven't finished it already. If you've already finished 4.3, don't worry about it. You're good. If you haven't finished 4.3, well, now would be a good time to do that. So 4.3, I think I just assigned questions 1 through 10. So that's page 240 to 241. So yeah, definitely do as much as you can. And then in tomorrow's live stream, we'll do a few more questions with the quadratic formula, and then we'll be pretty close to being finished chapter 4. So that would be pretty cool. So yeah, again, if you have any questions, don't ever hesitate to send me like an Instagram message or an email. I've been thinking a little bit about having a Discord for this class. I've been using Discord for my, excuse me, I've been using Discord for another one of my classes, and it worked pretty well. So if you have any suggestions about live streaming, you guys probably know more about live streaming than I do. This is, today was pretty much my first day live streaming. I've been doing it since 9 a.m. so I don't have a lot of experience with it. So if you have any pointers or any sort of requests or comments or anything like that, don't hesitate to let me know. I won't be offended. I'm learning just like you guys are learning. So yeah. In any case, tomorrow we'll look more at the quadratic formula, and I hope that we all have time to tune in and you can take part. And I also hope that you guys are doing well. I know this is a very strange time, so I hope that your mental health is as good as it can possibly be in these weird and strange and uncertain days. But yeah, if you need anything at all, don't hesitate to send me a message, and I'll do what I can to help you out. Okay, I'm gonna sign off, and hope to see you tomorrow. I hope you see me tomorrow. Adios.